Ever look at a plane and think, how do all those miles of tubes not just shake themselves apart?
Right.
We're talking fuel, hydraulics, oxygen, the stuff that keeps a plane up in the air.
It's life or death up there, not like a leaky faucet in your bathroom.
And that's what makes aircraft plumbing so fascinating. So get ready to dive deep with us into the world of rigid tubing systems.
You'd be surprised what you can learn from a few pieces of metal.
We're going to break down the basics, what these tubes are made of, how to read those weird markings on them, the art of bending metal without, destroying it.
It's trickier than it looks.
And then there's the unsung heroes, the fittings.
Those little guys can make or break a flight.
So first things first, why rigid tubing? Wouldn't it be easier to just use flexible hoses?
Well, you gotta use the right tool for the job, right? When you need something to handle serious pressure, literally rigid tubing is the way to go.
Makes sense, I guess.
Think about the hydraulic systems. Those control the wings, the tail, all the big movements. You need something that can withstand incredible forces, thousands of flight hours, and not fail.
So flexible hoses are okay for some things, but when it comes to those big, important systems,
Rigidity is key. Imagine building a house and using garden hoses for your plumbing.
that'd be a disaster.
Exactly. And just like you choose different materials for your pipes at home, aircraft tubing comes in a bunch of different materials.
Our sources mention steel, aluminum, even copper in those old-timer planes.
Yeah, each material has its pros and cons. You want something strong, lightweight, and able to handle high altitudes without, falling apart.
Corrosion's a big deal up there, right?
Huge. That's why they use corrosion-resistant steel like 316 grade. Super strong, super reliable.
What about aluminum?
Aluminum's great for saving weight, which is huge in aircraft design. Strong enough for most applications, too.
And copper. I bet that's a whole other story.
Oh yeah, copper's got a lot of history. They used it a lot in older planes. Had to treat it carefully, though. Annealing and all that jazz.
Sounds complicated.
It is. It's actually amazing to see how far material science has come since then.
All right, pop quiz time. You're a mechanic, you're thousands of feet in the air, and you need to replace a section of tubing.
Uh-oh.
You look at the markings and it's just a jumble of numbers and dashes. What do you do?
Hopefully you were paying attention in mechanic school. Those markings tell you everything you need to know about the tube, size, material, all that.
It's like a secret code, but instead of treasure, it's keeping a plane in the air.
Exactly.
Speaking of codes, our source talks about OD, wall thickness, and inside diameter. Can you decode those for us?
Sure, it's all about being super precise, even down to the tiny measurements. OD is the outside diameter.
Okay, that makes sense.
They measure it in 1/16 of an inch, usually. So a -6 tube would be 38 diameter.
Got it. What about wall thickness?
That's just how thick the wall of the tube is. And then there's the inside diameter, that's the space inside where the fluid flows. You get that by subtracting twice the wall thickness from the OD.
So it's like the actual space inside the tube.
Yep. And it matters because, well, think about a garden hose versus a fire hose.
Totally different.
Right. The inside diameter determines how much fluid can flow through.
Oh, so like too small and you get a trickle, too big, and
And you might not get enough pressure for the system to work right. It's got to be just right.
so these markings aren't random at all.
Not at all. They're like a language that ensures everything in the plane is working in sync.
And I'm guessing a miscommunication could be bad.
Let's just say the stakes are a lot higher than a typo in an email.
Understatement of the year.
Huh.
Okay, we've got our perfectly measured tubes. Now, how do we bend them without causing any weak points?
The art of tube bending. It's all about those smooth, gentle curves. You don't want any kinks or flat spots.
Why are smooth bends so important?
Think about kinking a garden hose. What happens?
No water comes out.
Exactly. The same principle applies here. Any imperfection in that bend can mess up the fluid flow. Pressure drops, turbulence, even damage to the tube itself.
So no sharp turns allowed.
Nope. Smooth and consistent, that's the name of the game. And to achieve that, there are different techniques.
Like what?
Well, there are mechanical benders, but for smaller tubes, sometimes you gotta do it by hand.
By hand? Seriously?
Yeah, it's a real skill. Takes years of practice to get those bends perfect.
Yeah.
Too much force and you kink the tube, too little and it's not bent enough. It's all about finding that sweet spot.
I can't even imagine.
And then there's the one bend minimum rule.
One bend minimum. You mean even if you could run a tube straight, you still like to put a bend in it?
Sometimes, yeah. It sounds counterintuitive, but it all comes down to vibration.
Vibration.
Planes vibrate a lot during flight. That single bend acts as a shock absorber, allows the tube to flex a bit without putting too much stress on the system.
So it's like suspension, but for plumbing.
Exactly. That one bend helps prevent something called metal fatigue. Basically, tiny cracks that can form over time because of all that shaking.
So one bend could be the difference between a smooth flight and, well, not a smooth flight.
You got it. Small detail, big impact, just like everything else in aviation.
Okay, so we've got our tubes measured and bent. Now it's time to connect them all. Let's talk fittings, those little guys that hold everything together.
Those little guys are more important than you might think. A weak fitting can mean a leaky system, and a leaky system can mean...
Let's not even go there.
Right. So there are two main types of fittings, flared and flareless.
Flared and flareless.
Okay, think of it like this. You're tying two pieces of rope together. You could tie them directly, or you could use a knot for a more secure connection. Flared and flareless fittings are kind of like that, different ways to join two pieces of tubing so they don't leak.
So flared fittings are like...
They involve flaring out the end of the tube, making it wider. Then you use a sleeve and a nut to clamp that flared end onto the fitting.
And flareless.
More like a compression fitting, the kind you might use for plumbing at home. Instead of a flared end, they use a ferrule, basically a ring that gets squished onto the tube when you tighten the nut.
So when would you use one versus the other?
It depends. Flared fittings are good for lower pressure systems and softer metals like aluminum. Easy to put together, easy to take apart. Flareless fittings are tougher, can handle higher pressures, and work with more types of metals.
So, like always, choosing the right tool for the job.
Exactly. Now, about those flared fittings, specifically that sleeve and B-nut combo they mentioned.
What's the deal with that?
It's the classic setup. You've got the flared tube, the sleeve, which is like a little ring that helps distribute the pressure evenly, and then the B-nut, which is what you tighten to create the seal.
Sounds simple enough.
It is, but there's one important thing to remember. You gotta be careful about using dissimilar metals.
Dissimilar metals, like mixing and matching.
Right. Because if you get it wrong, you risk something called galvanic corrosion.
Galvanic corrosion. That doesn't sound good.
It's not. You know how if you leave a steel tool out in the rain, it rusts?
Yeah, my dad's always yelling at me about that.
That's corrosion. Galvanic corrosion is similar, but it happens when two different metals are touching each other and there's an electrolyte present. Like water.
So what does that have to do with airplanes?
Well, imagine you have a steel fitting and an aluminum tube. The aluminum will corrode way faster than the steel. That's why they have those color-coded AM fittings.
Oh, right. The black ones for steel, blue ones for aluminum.
Exactly. They're color-coded so mechanics can tell at a glance what's compatible with what.
That's actually really clever.
It is. It's a simple system, but it prevents potentially disastrous mistakes.
And it highlights that even something as simple as a color can have a huge impact in aviation.
It all matters.
Speaking of things that matter, we've talked about the main parts, but what about those behind-the-scenes details, the hidden codes and things that most people don't even know about?
Oh, the stuff they don't put in the brochures.
Exactly. That's what we're going to talk about next. Back again with more aircraft plumbing.
We're diving even deeper, trust me.
Last time we were talking about those color-coded fittings.
Those markings are like the first page in a whole dictionary.
You got that right. So what other secrets are hidden in plain sight on these planes?
Well, you ever notice those bits of colored tape around some of the tubes?
I've always wondered about those. Usually yellow, sometimes red.
Those are like warning labels for mechanics.
Like, don't even think about touching this.
Pretty much. For example, if you see a marking that says PHDAN.
PHDN.
Yeah, PHDN. It means whatever's in that tube is physically dangerous, flammable, corrosive, you name it.
Yikes. Those color-coded fittings are starting to look pretty friendly now.
Right. Safety first, always. But there's more to it than just warnings. Let's talk about deburring.
Deburring, what is that?
Okay, imagine you're eating something, right? And there's this sharp piece of metal in your food.
I'm going to be calling the restaurant.
Exactly. Now imagine that sharp bit of metal inside a fuel line.
Not good.
Not good at all. That's why they do deburring. It's smoothing out any rough edges after a tube is cut or bent.
So no metal splinters in the fuel lines.
Precisely. It might seem like a small thing, but trust me, it's crucial.
So you're saying deburring is like giving the tubes a nice, smooth finish.
Exactly. So there's nothing to snag or create a weak point. It's all about the details in aircraft plumbing.
Like that 75% rule we talked about before.
There you go.
Why was that, again? Something about the bend diameter?
It's got to be at least 75% of the original tube diameter.
But
Any tighter, and you restrict the flow.
so the fluid can't flow as easily if the bend's too sharp.
Think of it like designing a racetrack. You wouldn't want a sharp turn on a straightaway.
Slows everything down.
Exactly. Fluid needs a smooth path to flow efficiently.
Wow, I'm learning so much. So we've talked about all the different parts, but how does it all fit together up there in the plane?
It's like a giant 3D puzzle, right?
Seriously,
Yeah.
with different types of lines running everywhere.
Exactly. You've got your supply lines, your return lines.
Pressure lines, right.
Yep. And don't forget about the vent lines.
Vent lines, like those things on my coffee maker.
Those are important too, but in an airplane, those vent lines make sure there's no trapped air in the system.
Because air bubbles are bad.
Imagine an air bubble in your fuel line.
No fuel means no flying, I'm guessing.
You got it. Vent lines keep everything flowing smoothly.
Just like our own circulatory system, but with fuel instead of blood.
Exactly. And just like our bodies need checkups, those systems need constant care.
Speaking of, we haven't talked much about the people who actually work on these systems.
Ah, the mechanics. They're the unsung heroes.
So it's not all automated robots doing the work these days.
Thankfully not. Behind every one of those tubes and fittings is a highly skilled mechanic.
So they need to know what they're doing.
They're like the doctors of the airplane. They diagnose problems, make sure everything is tip-top.
I bet they use some pretty cool tools, too.
Oh, you have no idea. But that's the story for the next part of our deep dive.
We're back and ready to wrap up this deep dive into aircraft plumbing.
We're cleared for landing, with a final look at the human side of things.
Right. Last time, we were talking about the mechanics who keep those systems running smoothly. What kind of tools are we talking about here?
Well, before they even touch a tool, a good mechanic, they can spot a problem just by looking at it.
Really?
Oh, yeah. Well, discoloration here, a tiny scratch there.
They have like eagle eyes.
You could say that. But of course, they use tools too. Borescopes, for example.
Oh, borescopes, those tiny cameras, right?
Exactly. They can snake those into tight spaces to get a good look at things, see if there are any cracks, any corrosion.
So it's like a tiny inspection robot.
Pretty much.
Uh,
And they use ultrasonic detectors to listen for leaks.
Listen, how do you listen for a leak?
These detectors can pick up on those super high-pitched sounds that leaks make, sounds we can't even hear.
Wow. So they're listening. What
Oh,
else?
no. Once they find a problem, they gotta fix it, right? That's where things like flaring and swaging tools come in.
Flaring tools, I get. But swaging? What even is swaging?
It's basically a way to shape metal by, like, squeezing it really precisely.
Squeezing metal. Sounds intense.
It can be, but it's how they create those super tight seals for flareless fittings.
So like every connection has to be absolutely perfect.
Pretty much. And speaking of perfect, one of the most important things they do is pressure testing.
Pressure testing.
Yeah, after they've inspected everything, they use special equipment to simulate the pressures those systems experience during flight.
So they basically crank up the pressure and see if anything breaks.
Something like that. But they're monitoring everything very carefully, looking for leaks, pressure drops.
I bet that's pretty nerve-wracking.
It can be. But that's why they have all those procedures in place, to make sure everything is done right. Because even a small mistake can have big consequences.
That's true for everything in aviation.
It really is, and that's why the human element is so important. Because even with all the technology in the world, it still comes down to people making sure those planes are safe to fly.
So those mechanics, they're not just fixing tubes and fittings.
They're keeping people safe.
That's a pretty important job.
One of the most important.
Well, on that note, it looks like we're ready to land this episode.
Safe to say, we've plumbed the depths of aircraft plumbing.
I think we did. Thanks for flying with us, everyone. We'll catch you on the next deep dive.